It's the most exciting part of this class. Okay.
So what we got last time, we did a problem together. We did a lot of probability problems. I want you guys to realize we did a lot of problems before we had any formulas, correct? Because the basic idea of probability does not change. Okay. If I'm given everything that I need to count, I don't need any formulas. Because probability is just the number of things that match what I'm looking for divided by the total number of things. Are you guys with me so far? Okay. All right. Okay. Let's do a quick little recap. What if I had Queen Maka students, Grossmont students? I don't remember. That's the same thing I did last time. I don't care. Yes, no. I asked them a question, and let's say, I think this is exactly what we did, and I apparently don't care. Okay. So just make sure everybody remembers. What does that 19 mean?
19 Queen Maka students said no.
19 Queen Maka students who said no. I love it. So what do I kind of do, knowing this is going to be probability questions I've got? What do I want to do with what I've got here? What do I want to find? Considering probability is divided by the total number of things, what do I want to do with the numbers?
Add them all together.
Add them all up. So how many yeses?
11.
How many no's?
23.
23. How many Queen Maka students do we talk to? 24. How many Grossmont students? Is that the appropriate proportional amount? No, but oh well, too bad for us. 34, right? You gotta check and make sure it's gonna work both ways. Triple check this number, because where's 34 gonna go in almost all of your answers? Where's 34 gonna be in all of the almost all of the probability questions? Where will you put 34? On the bottom. If it's wrong, if you added incorrectly, all of your answers are wrong. Automatically, right? So thankfully, I take points off once for miscounting, and then I just treat it, as long as you get them all right based on the wrong number, I don't take any more points off. Do you guys understand? This is why you're happy I don't do Scantron shit, right? In fact, quick thing about Scantron, if you have a math teacher who uses Scantron test, they are not a math teacher. I don't know what they are. Yeah. You heard me. Because that's shit. Math is all about the work. Math is all about your thought process. Scantrons don't belong in math. They just don't. Okay. So if I ask you, if I pick one person, ooh, you're good. I stole these from somebody. Oh, crap. All right. If you pick one person, what's the probability that you pick a Grossmont student?
10 out of 34.
10 out of 34. I like it. And do you guys remember what I said about how much to round the decimal answer to? 4 places. I love it. Kick ass. So whatever the hell 10 divided by 34 is. It's like 0.2987. I don't know. I have no idea. I'm making that shit up. So, somebody help me.
.29411.
It's not bad, right? Is that all right? Can I keep going? Do I have to stop? 0.2941?
Yeah.
And then you can make that 29.41%. So real quick, where is my work in the problem I just did? Where's my work?
The decimal.
Good. Oh, no. Where's my work? The fraction.
Fraction.
That's my work, and then that's the answer. And then you can make it in percent if you want to. All right, it's up to you. Okay. So immediately, let's do something more interesting. What's the probability I pick a Queen Maka student? And they said no. So if I pick one person, what's the probability I get a Queen Maka student who said no? So and.
19 out of 34.
Yeah.
19.
Right? Cuyamaca students, and they said no, 19 match what I'm looking for out of 34 total. Is that cool? I'm thinking it's gonna be 0.5637.
No.
5580.
What is it?
0.5588.
5588? Okay. Was that close enough? Can I keep going? You guys gotta tell me. It's like, pack it up, math boy. It's not close enough, but, okay. Not too bad, all right? We don't need any formulas. Because it's very simple. Why do I not need formulas for this problem? Because I gave you everything to count. And probability is all about counts. So when I don't give you anything to count, that is the one time you need a formula. Would the formula still work here? Oh, hell yeah. They'll actually make it harder than it needs to be. All right, so what about this? Let me jump to this just to freak things out. Yeah, girl. Probability is said yes, given that they're a Grossmont student. I showed you this symbol, right? The little, that means given. So
5
what?
out of 24.
Let's see.
Or wait, I was looking at Cuyamaca. 6 out of 10.
All right, I like it. So what do you know about the person? In the question, what do you know about the person?
They're a Grossmont student.
They're a Grossmont student. You gotta be careful. Probability of this, so I don't know if they said yes. Given they're, okay, so I know they're a Grossmont student. That's why the bottom changes. The bottom is everybody they could be. It's not 34 anymore because now I throw out all the Cuyamaca students. So it can only be out of 10. And out of those 10, how many match what I'm looking for? 6. See what I'm trying to do and I can't quite? So this is nice. This is 60%. 0.6000. Just to make Jeff happy. No, you don't. You can just put 0.6. It's fine. Okay. Not too bad, right? And of course, you know, what about probability of a Cuyamaca student, or they said yes? Curious. Cuyamaca, or they said yes.
Wouldn't that be different numbers?
What do you mean?
Like Cuyamaca students would be 24 out of 34,
Sure.
and yes would be 11 out of 34.
Sure.
So,
But remember,
oh, you add them together.
maybe,
Is it 24 or
maybe
5?
that's a good first step, but not the end.
30 out of 34.
How do you get 30?
You add up the Fremont students and the yes students, but then you subtract 5.
Good. If I add these students to these students, didn't I add these twice?
Okay.
And remember, what's the idea of probability? The total number of things that match what you're looking for. Okay, I'm looking for Cuyamaca or yes. I'm going to count both of them. But I can't double count anybody. Although many people in today's election wishes they could be double count. Too bad. All right, I like it. Love you guys.
So did you take away 5?
Yeah, exactly.
Okay.
So let me put it down. I'll stop trying to make stupid jokes. 24, that's the only jokes I make. 24 plus 11, I could do this, but then I better subtract the ones I counted twice. Why is the bottom still 34?
It's out of all students.
Why? How do I know that?
Because denominator is not given.
Okay, good. I didn't give you any information, right? The problem didn't give us any information. It could be any of the 34 students. It has to be given information. That's when the bottom will change. A lot. Good. And so what do you hear? You get 30 out of 34, which is also known as something. Is that? I feel like we did that. No? Oh, yeah. That's right.
Point. Are you looking for the decimal?
Wait, points. 0.87.
No.
0.8823.
Yeah, actually, but I rounded up to 2.4 because it's a 5 after.
Oh shit! All right. Well, damn it, Jeff. No, I have to retire. probabilities. All right, moving on. We'll get through this together. Okay, now, we did this, and then I'm just going to kind of cut to the chase here. We looked at what we did, and we developed formulas for what we did. So, for example, the probability of or is the probability of one guy plus the probability of the other guy. Jeez, Jeff. Divided, minus, what's the 5 mean in that problem over there? Who were those people?
Double counted.
They were this and this, right? So minus any that are both. Now look, visually I could say, okay, if I take everybody in A and I take everybody in B, who did I double count? Who did I double count? Everybody in A, and I take everybody in B. Who did I double count? Did I double count these people?
Yeah,
Who are those people? That's A and B.
combined.
That's people that were in A and B. So I can do A stuff plus B stuff, but then I better subtract one of these off because I counted them twice. Right? You can't mail it in and go to the polls. No. We got to subtract one of the votes out. Okay. I like it. And then, probability of A given B. We look at the given. Where did 6 come from?
Yes.
It was yes and Grossmont, right? It was this and this. And of course, where did 10 come from? Grossmont, because I knew that. So here's what probably A given B is. On the bottom, it's related to the given. Whatever the given is. And on the top, it's got to be A and B. So visually, if I know that B happened, given that B happened, what is the only way that A could also have happened? Could that A have happened? If this is what happened, what is the only way that A could have happened also? Where
In the
does it have to
small
be?
circle.
It's got to be in there somewhere, right? That's A and B. So what's the chances that A happened given that B happened? A and B divided by B. If you hate both of those ways to think about it, I'm really sorry. I've run out of different ways to give it to you. Now, I really want you to understand. We developed the formulas based on what we did. We did not use the formula to get the answer, did we? You're not used to that, are you? Normally you get the formula, then you can do stuff. All right, now, what's the one I haven't talked about yet? What's the main probability that we haven't given a formula for yet? In fact, it shows up in the other guy's formulas. I got a formula for or, I got a formula for given.
A and B.
I don't have a formula for and yet, right? And you guys are like, that's okay, Jeff, we're okay, you don't have to give us another. No, screw that. I'm gonna erase all this shit.
Okay.
Someday, I'll be done erasing. All right. Lord, I really wanted to stay. Okay. Now, to do and, all right. There are 3 things I want to do. 2 of them are discussion, and the third one is actually algebraic manipulation to develop the formula. Ooh, that sounds exciting. I've got 2 situations that I want to talk about with and. One of them is silly, one of them is tragic. Which one do you want to start with? Tragic, that's a good idea. Let's end on silly. Does anybody know how many times the space shuttle blew up?
Twice.
Twice. Obviously it wasn't the same one, right? So it sucks that I have to talk about it in terms of which one, right? So the first time it was in '86, young Jeff, I still remember I was in English class. We lived in Florida, I lived in Florida, not we, I lived in Florida, and we would normally go out and watch the takeoff. We would go out and watch the takeoff. For some reason, we didn't do that. I will never forget, I'm in the first row, because the door's right there, and I want to get the hell out when class is over, right? I'll never forget exactly where I was, what we were doing, because then one of the announcements, they said the shuttle's blowing up, and Jeff just started crying. I mean, I was just, tears just flying. Because I was, you know, I'm a geek, as big as geek dude, right? So I was all about the spaceship. Does anyone know why that shuttle blew up?
The O-rings.
Ooh, look at this. All right, sorry. I'll come back. So, O-rings were where? Do you know?
The boosters, I think.
All right, but they were in the fuel line,
Yeah.
right? Okay. So in the fuel line, what do you not want the fuel to do in a fuel line? You want it to go one direction, not the other way, right? So the O-rings were sort of like valves to keep the fuel flowing in one direction. That morning was icy. They didn't operate at maximum efficiency. So normally, so let's find out. Why would I have, look, I've drawn 2 O-rings. Why would I have more than one?
So in case one breaks down,
Yes,
backup.
in case one breaks down, the other one's a backup. Sort of like, have you ever had like a very crazy important test, and you want to make sure you wake up in time? What do?
Set multiple alarms.
Multiple alarms. Call your friend. Say, hey man, I know you get up early. Can you call me? And all these alarms. You leave the curtain open so the sun's in your face. All this kind of shit. Why do you do that? Because if one fails, you got contingency plan, right? Which means the probability, so if, let's say, and this is not true, but let's just say this is a 1% chance of failing, right? Obviously, to find the overall probability that this whole thing fails, I'm not going to add them. That would make no sense. Multiple ones in there should decrease the probability they fail, right?
Yeah.
I like it. So if this fails 1% of the time, right, this fails 1% of the time, what percent of those times would this one also fail? 1%. I really want this to make sense. If there's a 1% chance it's going to fail, 1% of the time it's going to fail, right? So if you blast this thing off 100 times, this is going to fail once on average. You guys with me?
Yeah.
Okay. Sort of, all right. So 1% of the time, this guy's gonna fail, and 1% of those times, this one's also going to fail. What does of mean?
Division.
Multiply.
Yes.
Yes. Division means multiplication of the F. So I would then just multiply these together. Now what's beautiful about multiplying numbers that are less than 1 is they get smaller. That's the only time. Normally you multiply 2 numbers, it gets bigger, yes?
Yeah.
But for example, what's 0.9 times 0.9? It is 0.81. It got smaller. So what is 0.01 times 0.01?
0.001.
No? More.
No. Okay, just checking.
1, 2, 3, 4, right? 1, 2, 3, 4.
Okay.
Yeah. So if 1% chance of failing for 1, once I have 2 in a row, what is this? This is a 1 out of 100 times a 1 out of 100 was 1 out of 100, which is otherwise known as 10,000. Yes?
Okay.
So it's got a 1 out of 10,000 chance of failing. If I put a third one in there,
Not
I'm
failing.
feeling pretty good.
Yeah.
Right? Now, unfortunately, like I said, that morning was icy. These numbers went way up. And then, of course, it happened. Right?
So they announced it over your school speakers?
Yes.
Okay.
Because again, I was in Florida. It was a big Florida thing. I have no idea, to this day, I have no idea why we didn't go out. We would almost always go out to watch it because you could see it when it came up over the neighborhood buildings. You could see it. And if I was at home, I'd go out in the court and I could see it over the the guy's house down there, I can see it going up, right? But for some reason, we didn't go up. I have no idea when.
Are you mad you missed it?
Not after I found out what happened, because, I
If you
mean,
wanna watch it like explode.
Were there people on
I
it?
feel like that would be kind of awful.
I still watch sometimes the people that were there, and of course the parents of the one teacher that was on the thing. When they see it happen, they think for a minute, oh, this is something special they did. And then eventually they realize, what happened. Anyway,
Oh.
so, anyway, sorry. What a bummer day.
Yeah.
I'm sorry. Okay. Now, why is this relevant to an idea of and? Well, what's the only way that this is gonna fail? If this one fails, and this one fails. So the probability that this one fails, and I'm gonna call it F1 and F2. The first one fails, the second one fails. Is that cool? Whatever the hell the letters are for the events, right? This would equal the probability of the first one failing times the probability of the second one failing. Normally, right? Okay. So this seems like maybe and is based on multiplication, right? Can somebody, I've got it right up here. What is or based on, basically? What is or based on? What operation?
Subtraction.
Not really. It's based
Addition.
on addition. And the subtraction is a adjustment if there's overlap, right? If there was no overlap, wouldn't it just be that?
Yeah.
I wouldn't have anything to subtract. So it's basically addition with a little adjustment, and so far seems to be multiplication. Okay, two more things. Silly one, real quick. All right, let's say I'm about to join some kind of a club, and they do this little initiation. I've got to walk down this hallway, right? It's lined with a bunch of doors. Every third step I take, somebody slaps me on this cheek, right? And every fifth step I take, somebody slaps me on that cheek. Yes?
Okay.
So I got a 1/3 chance to get slapped on this cheek, yes?
Yeah.
And a 1/5 chance to get slapped on that cheek. How often do I get slapped on this cheek and this cheek? Every third step, bam. Every fifth step, bam. How often? Bam. How often do I have a Home Alone kind of thing? No? Okay, fine. How often do I get hit on both cheeks? Think about it. Come on, think. Don't look at me. Stop looking at me. Look.
Every
Are you
1 in
kidding?
15.
Let me make sure everybody's with us. Does that make sense? Please let that make sense. Every third step, bam. Every fifth step, bam. When do those match? 15. What's 1/3 times 1/5?
115.
1/15. So again, and seems to be multiplication. So now, okay, so let's do the real proof. All right, if I take this formula right here, I don't know if red's gonna work. Come here, red. Is that all right? You guys
Yeah.
can see that? Everybody, okay. I know sometimes people that are colorblind can't see it as well, so just let me know. Probability of A given B. I only have A and B. Probability of B. Well. Wow, I can smell that through my mask. Okay. How do I solve that for and? How do I solve that for the probability of A and B? It's just one thing I gotta do.
Multiply.
Right? Is everybody with me? With us? Okay, so if I multiply both sides by what? Somebody else? Everybody was like, totally with you, man. Tell them what. What do I multiply by to get the and piece by itself?
Probability of B.
Yeah, I multiply by the probability. So it cancels. Let me put it here. Oh, let me put it down here. So probability of B times probability of A given D equals the probability of A and. Notice, okay, let me put these guys together. Where'd my really good one go? There you go. Oh. Okay, here's the or, here's the and. Or is basically add, but it's got a little bit of an adjustment, yes? And is basically multiply, but it's got a little bit of an adjustment. It's not just the probability of one times the other, is it? You guys follow?
Yep.
This doesn't say probability of A times probability of B. It doesn't. It's a little bit of an adjustment. But and is basically multiply, or is basically add. I've said that a few times. So it seems like it's going to come back to bite us in the ass if we're not careful. Okay. All right. Now, let's do an example to see how this really works. Okay. So let's say, let's do this because I know a few people don't really know cards too well. Let's say let's go back to our bag with, I've got 4 green poker chips, 5 blue poker chips, and 11 red poker chips. Okay. Pretty straightforward. Much better than cards. For everybody. No, you suck. Okay. Real quick, if I pick one poker chip, what's the probability that it's blue?
5 out of 20.
Yeah, 5 possibilities out of 20 total things. So that's going to be 1/4, 25%. Okay, now, if I pick 2 poker chips, I have to tell you how I'm going to pick them. Believe it or not, I have to be very specific about how I'm going to pick them. Wouldn't it be different if I picked one and then dropped it back in and then picked another one?
Yeah.
From picking one, feeding that to my little brother, and then I go in to pick another one. Do you guys understand those would be different?
Yeah.
What happens on the second pick?
You have one less chip of one.
I would have
specific
one
color.
less chip, so the denominator would change every time I take another one if I feed it to my little brother, or throw it away, or whatever. Okay, so if I pick 2, I gotta tell you, I'm gonna pick 2 with replacement. With replacement. Meaning, I pick one and then I drop it back in. And then I pick another one. So every time I pick one, the bottom stays the same. If I did it without replacement, the bottom would change every time I picked another one because I keep losing chips. Okay. Maybe. So what's the probability I get a green and then a blue? Let's work this out. Nothing's happened yet. I reach in, I grab a chip. What's the probability that it's green?
20%.
Yeah, 4 out of 20. 20%. So let me just put a 4 out of 20. Then I drop it back in. Bam. Let somebody else tell me, what's the probability I reach in and get a blue now on the second pick? Yeah, I dropped that one back in, so it's all back, it's reset. So the probably get a blue one now is 5 out of 20, so it's gonna be times 5 out of 20. So in this case, wasn't this the probability of green times the probability of blue? Yes. Really? Stay with me. And is multiplication. I'm going to have to adjust sometimes. Would you say that this probability depends at all on what happened here? Does my second pick depend on what happened with my first pick? If I threw that first one away, would my second pick depend on my first pick? Yeah, because if it was a blue, I got less blue. If it was a green, I got less green. And no matter what, I got freaking less chips. Yes? But in this case, I put the damn thing back in. So this is what we call independent. This would be two independent events. This one is independent from what happened here. It didn't give a shit because everything reset. So what does this come out to be?
20 over 400.
Yeah? Or even better.
Do you want me to
20
keep-
divided by 20, 1 divided by 25%, right?
Yeah.
0.05. All right, you guys do this one real quick. Same thing, pick 2 with replacement. Don't say anything. So probably get a red and then a red. Don't say anything, just do it. So what I always like to do is like a little hangman game. I'm doing 2 things, right? I'm doing 2 picks. So first pick and times second pick. So what goes here in the first pick?
11 over 20.
Yes. And then of course I drop that one back in. So of course the next one being red has the same chance, right? Or 30. That's like, let me think. 0.30 something. Yeah.
3025.
3025?
Yep.
Neato. So I don't know if you picked up on the fact I can normally get this, and it's this that I guess on.
Yeah.
Yeah.
Sure.
All right, not too bad, right? All right, so what's going to happen if I don't put that one back in? If I take it out. By the way, real quick, let me say this. We are doing an incredibly, really basic, who the hell's going to worry about this shit, yes? And of course, we're doing this just to get used to the mechanics of what we need to do, the math. How does this translate to real life with stuff that we care about? Well, for example, just to pick on COVID, have you heard the statistics that right now you're 11, I think the last thing I heard was you're 11 times more likely to get COVID if you have not been vaccinated? Have you heard about it? Anybody? So that is a probability calculation, yes? Probability calculations tell us what we should do. What people do not understand is that the vaccine lowers the chance you're infected. Does that mean you cannot get infected? No, it just lowers, now when I say just lowers, it lowers the chances by quite a bit. But of course, we're still going to get some breakthrough. So I sometimes run into people who do not understand math at all, do not understand science at all, but believe that they do. Yes? And they'll say stuff like, 98% of people survive this thing, what the shit, man? And you're like, okay, what would 2% of all Americans come out to be? Do you guys know? 2% of all Americans would be over 6 million people dead, yes? So if you ever hear somebody say, 90% chance to survive, 2 things. That's a lot of people dead. And surviving doesn't mean you're great, yes? I'm sorry, I feel like I'm lecturing to you. This is really all about the probabilities, understanding probabilities. So many people make stupid choices because they do not understand the math. And I want you to understand, people know that most other people do not understand the math. A lot of politicians know all too well that the people they're talking to when they have big press conferences, they don't understand math. So they can completely mislead people into whatever, because they don't understand what the math means is coming out of their mouth, and they know all too well. Anyway, sorry, I'll stop. It's just really frustrating. Okay. So, what about when we don't replace? Let's see. Take this away. So if I pick, same problem, pick 2 without replacement. What letter is that? Okay. Sure. Let's do this probability again. Where am I at? I'm on Roman numeral 4. What's the probability that I get a green and then a blue now? It's not going to be the same as before. And by the way, why do I need the formula for this? Because I know about picking 1. I don't have it set up for picking 2. I don't have all of that. I'm not able to count all the ways to do GG and BB and GR and BR. You know. So I need a formula to help me out. All right. So I know it's and. I got 2 things. 1 times another one. Nothing's happened yet, so of course the probability I get a green is just going to be, so when I do my very first pick, nothing's happened yet, it's probably get a green.
4 to 20.
4 out of 20. And then I throw it away. Wah! Come to 0. So it's gone, right? That green one is way out there. I hit somebody. I'm sorry. Yes.
So all 4 of the greens go, or just one?
How many did I just pick?
4. Like, there are 4 greens out of 20.
What does this 4 out of 20 represent?
1 out of
The probability of picking
Green.
1 green. So let me ask you again, how many chips have I picked so far?
1.
1. The 4 is just because I have 4 chances to get a green. Now, if I go and grab 4 chips, have I done what they asked me to do? No. If I throw all of those away, the problem's like, the shit, right? Okay, maybe. I like it. And the people behind you are like, I need to pick a poker chip, and that guy just picked 4 through to what the shit? All right. So now the next person comes along. What's going to be true about this now? What's the bottom going to be?
19.
19. You guys are all ready for that. How many blue are still there?
We don't know.
Yes, we do.
5.
Well-
Okay, I know exactly where you're going.
Wait, I think I know where I'm going to.
Sweet. Okay, that's all right. If you really do, it's better if we don't discuss it, because then,
Yeah, don't even confuse anybody.
okay. Again, so this is just the probability I pick a green, correct? I don't know what I could. If I reach in, do I have to get a green?
No.
No, this is the probability I get a green. On the times that I get a green, the probability that I then get a blue will be, how many blue?
5.
Because I didn't pick a blue, right?
Yep.
Okay. And then this one, those canceling, guys, go, I don't know. You just put all that shit in the calculator. What is that going to be, math boy? 05, 4, 1.
You're like disturbingly good at that.
What is it?
It's 0526.
0526? No, it's because you're excited about this, which is the easy part to get. This is the hard part to get, which is why I'm always wrong about this.
Yeah, but I don't know what the first 2 are.
All right, let me real quick,
I can't even
real quick.
do, like,
You ready?
6 in my head.
You ready? 1/20 should be relatively easy, because you can just multiply by 5. Is that cool? Is that cool, right?
Yes.
Isn't this 1 out of 19? If I cancel all these, isn't that 1 divided by 19?
I don't know.
Stay with me, stay with me.
What do you think about the rest of the numbers?
No. 4 times 5 is 20, which cancels with that 20, yes?
Yes.
Okay, so I'm left with 1/18, yes?
Yeah.
1 divided by 20 is 0.05. 1 divided by less than 20 should be more than 0.05. That's one little trick that I use. So if I did 1/21, I would have said 0.0483 or something. A little bit less than 0.05. I shouldn't be explaining this. Well, I should. You should know this. You should, as a human being, we should know how numbers kind of work. And I also know that we have these things called calculators. I'm aware of that. So you can keep using those. Okay. It doesn't matter. At the end of the day, throw in the calculator again. What about now? What about this? Don't say anything. Try this one. Hopefully I've primed you so that you know something weird's going to happen here. R and then R. And every time I do this kind of problem, it always resets between problems, right? You understand
Oh,
that?
it resets, okay.
Yeah. This problem is done, everything resets. Because these are all probability questions. None of this actually happened. These are all, what's the chances that this could happen? All right, somebody who I haven't heard from yet. Anybody I haven't heard from yet can tell me what's the probability I get a red? I heard something. Anybody? What's the probability that I get a red? Or have I heard from everybody? Is that what it is? I feel like I haven't. I'm not going to point at anybody. But somebody else tell me, anybody. What's probably get a red?
11 out of 20.
11 red out of 20. I get that, throw it away. And again, this is the probability that I get a red. On those, thank you, on those times, what's probably I then get another red after I threw that first one away.
So the token's away, right?
Huh?
So you just took out the red from the 20?
Yes.
Okay, so then wouldn't it be 10 over 19?
Beautiful. So of course the bottom goes down because I lost a chip, but the top also goes down because I lost the red chip. Why didn't that happen up here? Because there was freaking green and blue. That don't give a shit about each other. Okay, maybe. So it's the same idea. You just have to be careful. I mean, I'm going to lose a chip, but if I happen to lose the same thing, the same kind of thing, color, in this case, the top's got to change too. Let's see, it's 1.5, 12, 6. It's like 30%, but it's like, I don't know which way it goes. 0.30.
Down.
I went the wrong way. When it goes down, 0.29?
Down.
2.8? All right. Now I should probably retire. Sorry. 2.8. What is it?
9.5.
9. Oh, that's, all right.
You're very close.
All right. As long as it's still, it's not impressive to me. I feel really bad. I've got that one wrong.
You should feel really bad.
There you go. That's
Just
what I
kidding.
need. I need somebody to agree with me. That sucked, math board. Okay. This isn't that crazy hard, is it?
No.
So, what's going to keep it straight is and means multiply, or means add. But both of them have times when they have to be adjusted, yes? No? So for example, last thing about this. If I pick 1, let's probably get a red or a green.
Are we doing it or yelling it?
15 out of 20.
There you go. Did you have to worry about subtracting anything? Because there's no reds that are also green, right? So, or means add, but you might have to adjust sometimes if there's any that's both. And means multiply. You might have to adjust sometimes if the second dude depends on the first dude. Okay, I know, it's pretty. All right, I think that's enough to get you. Well, all right, let's do one more thing, and then I got, believe it or not, I've got a worksheet. It actually says at the top, this side in class, so that should be pretty apparent which side we'll do. And the other one is a practice quiz that I'll have the answer key for, because this next quiz is like a double quiz. Okay. All right. What does a double quiz mean? What do you think?
2 quizzes, extra long.
It's
2
twice
chapters.
as long and it counts twice as much.
Okay.
It's crazy. I used to call it a mini test, and that freaked people out. But all right. Let's see. Yeah, one more thing to talk about. And it kind of relates to what we're doing here. All right, real quick. Wasn't a blue 5 out of 20
Mhm.
before, like by itself, a blue was 5 out of 20? Remember that problem we were just doing?
Yeah.
5 divided by 20, of course, is 0.25. Is that cool?
Cool.
Okay. What happens if I take one chip? What happens? What is 5 divided by 19 now? And I want exactly. I can give you some bullshit. But
0.2631578947.
all right. Next time I need you to be more specific, but that's okay. Just now, I want you. Let me see your reaction. Do you think that this is a big difference? Yes. Good. Yes, that is a big difference. That is a big difference. I like it. Now, what if I had? How many Americans are there
Lots.
in existence? Yeah.
It's like
330 million roughly. Somewhere, I think it is right at 330. I always think it's 340, but we've suffered some losses recently, so we're about 330 million. All right, so what if I had, out of those 330 million, let's say that 5 million like to play golf, whatever the shit, I don't care, right? What is that? Somebody help me out. What does that division come out to be? You can do it, Jeff. No, you can't. You're too tired. 65. So I don't know what it's going to be. How does that help you? I don't know.
0.0151515.
0 who?
15. Repeating.
151515. Okay. Now, stay with me. Stay with me. Is everybody kind of with me, guys? It's the same thing. It's just a bigger fraction because it's got more shit going on, right? I don't just have 20 chips. I got 330 million freaking people. But let's say I take one of them and I throw them out, right? I throw them out of the country. And they're probably like, yeah. So, what would happen then if I picked one? So now this is 4999999, and this is going to be 3299999. Okay. That could be your wake up alarm. 999. The German clock that just always tells you no. All right. Can somebody do that division for me?
Yeah. It's 0.01515151512.
Oh, yeah. Now, let me ask you, even in terms of Stickler, Geek, Jeff, are these very different?
No.
No, come on, no. Now's the time to say no. Look at when they first become different. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 11th decimal place. Right? And for most humans, even math people, that's not very different. The earlier one was 257 and then 26 something. It was different in the second decimal place. That's huge. So what's the point of all this shit? If I have a large population, I do not have to write them as fractions and keep reducing as I go because it doesn't really change things much. Not enough to worry about. So what does that mean? Give me an example, Jeff. Okay. I'll give you a really shit example. It's a shit example because I haven't looked this up in a while, but the last time I looked it up, 11% of Americans were left-handed. I almost feel like that has to be different now, but let's just go with it. 11% of Americans left-handed. Okay. So if I pick 2 Americans, what's the probability that I get 2 left-handed people? 2 Americans. What's the probability I get 2 left-handed people? I'll do it like this. Lefty and a lefty. Thank God I don't have to do this shit. I really want you to understand how big is the population here? 330 million, yes?
Yeah.
So I do not have to write the fractions. What can I do? What's the probability the first one's left-handed? 11%. Times, it's probably the second one's left-handed. About 11%. Maybe? Yes? No? Maybe? No?
Yeah.
Yeah, okay. No? Is that? So when I have what was the population for the chips? What was the population for the chips?
20.
20. Is that a big population?
No.
Hell no. So I had to do the fractions because if I take one away, the probabilities change by a decent amount. If I have a very large population, I don't have to write them as fractions. They just stay the same because they're not going to change much at all between. So what is 0.11 times 0.11? 0.0121.
Okay.
I cheat. Because I know what 11 times 11 is. It's easy. Guess? No?
Well, this is only, you can only do that when the population is big enough that
And
it
let
doesn't
me,
really
yes,
matter.
and let me be really clear about what big enough is, right? Big enough is very vague. You agree with me?
Yeah.
Is 60 big enough, Jeff? Probably not. When the number of things is less than 5% of your population, wouldn't you say that 2 people is less than 5% of 330 million? Do you even have to do the math? No. So most of the problems I'm going to do are going to be very obvious, but if you needed a specific definition, that's it. As long as the amount you're picking is less than 5% of your population, we'll go with it. So what was I doing earlier? Wasn't I picking 2 chips out of 20?
Yeah.
Isn't that 10%?
Yeah.
That's more than 5, that's why I had to do the fractions. Now I'm doing 2 out of 330 million. I don't need no frickin' fractions. Whew. Okay, now, let me finally shut the hell up. You guys are gonna work on this. Let's see if that makes sense when it gets back there. There we go. Sweet. You guys got it? Yay. So obviously the side that says this side in class, yes? Okay, I like it.